In this video, you'll learn what is welding and its process, its types, working, advantages, disadvantages, applications, and more. Welding is a permanent joining process in which two pieces of metal are joined together to form one piece by heating the metals to their melting points. Additional metal, also called filler metal, is added during the heating process that helps to join the two metal pieces together. In general, the welding is a process in which two metal pieces may be joined by heating them to a high temperature enough to fuse the metals. A welding machine is used to create the heat and apply the filler metal. The filler metal is supplied to form the joint, either from the electrode itself or by filler material. The temperature of the heat produced is of the order of 6,000 degrees to 7,000 degrees Celsius. So in this video, we'll discuss what are the different types of welding processes that are used in various industries. There are various types of welding processes can be done according to the method of heat generated. Number 1. MIG welding. 2. Stick welding. 3. TIG welding. 4. Plasma arc welding. 5. Electron beam welding. 6. Laser beam welding. 7. Gas welding. 8. Flux cord arc welding. 9. Atomic hydrogen welding. And 10. Electroslag welding. MIG welding. MIG stands for metal inert gas welding. This welding process is also identified as gas metal arc welding, which you can also call wire welding. In this types, a thin wire works as the electrode is fed from a spool attached on a gun through a flexible tube and comes out of the nozzle on the welding gun or torch. The wire is fed continuously when the trigger is pulled on the welding gun. Stick welding. Shielded metal arc welding. It is also identified as hand-operated metal arc welding, flux-shielded arc welding, or stick welding. In this type of welding process, the arc is struck between the metal rod or electrode and the workpiece, the surface of both the rod and the workpiece melting to create a weld pool. The simultaneous melting of the flux coating on the rod will produce gas and slag, which shields the weld joint from the environment. Shielded metal arc welding is a various process ideal for joining ferrous and non-ferrous materials, with the thickness of the material at all positions. TIG welding. TIG welding. TIG stands for tungsten inert gas arc welding. This welding process is likewise called as gas welding. This welding employs a tungsten electrode because tungsten has a high melting point. When we take the TIG weld electrode gets hot, but it doesn't melt, we say that is a non-consumable electrode. Non-consumable electrodes do not mean that it does not last forever, and it means that it does not melt and becomes part of the weld. Plasma arc welding. Plasma arc welding is an arc welding process utilizing heat generated by a compressed arc between a tungsten non-consumable electrode and workpiece or water-cooled constricting nozzle. The plasma is a gaseous mix-up of positive ions, electrons, and neutral gas molecules. The transferred arc process creates plasma jets of high energy density and can be used for high-speed welding and cutting ceramics, copper alloys, steels, aluminum, nickel alloys, and titanium alloys. Electron beam welding. Electron beam welding is a welding process that applies the heat created by a beam of high-energy electrons. The electrons hit the workpiece and their kinetic energy is converted into thermal energy, heating the metal so that the edges of the workpiece can be connected and a weld is formed after freezing. Electron beam welding is also a liquid-state welding process, in which the metal-to-metal joint is made in a liquid or molten state. It is also described as a welding process because it accepts electrons' kinetic energy to join two metal workpieces. Laser beam welding. Laser beam welding is a welding process in which heat is formed by a high-energy laser beam targeted on the workpiece. The laser beam heats and melts the ends of the workpiece, making a joint. In this type of welding, the joint is formed as a sequence of overlap spot welds, or as a continuous weld. It is employed in the electronics, communications, and aerospace industries to manufacture medical and scientific equipment, incorporating small components. Gas welding. Gas welding is performed by melting the sides or surfaces to be connected by gas flame and providing the molten metal to flow together, thus creating a solid continuous joint upon cooling. Oxygen-acetylene mixtures are used to a very greater extent than others and hold a prominent position in the welding industry. The temperature of the oxyacetylene flame in its hottest area is about 3,200 degrees Celsius, while the temperature reached in the oxyhydrogen flame is about 1,900 degrees Celsius. Flux core arc welding. This type of welding is almost similar to MIG welding. In fact, MIG welders can often perform flux core arc welding. In this welding, the wire has a core of flux that forms a gas shield around the weld. This reduces the demand for external gas supply. This welding process is better suited for rough, heavy metals because it is a high-heat welding process. It is usually used for heavy equipment repair for this purpose. It is a process that does not produce too much waste. Because there is no need for external gas, it also costs less. Atomic hydrogen welding. Atomic hydrogen welding is an extremely high-temperature form of welding that also known as arc atomic welding. This type of welding requires using hydrogen gas to shield two electrodes formed of tungsten. It can reach temperatures above an acetylene torch, and it can be done with or without filler metal. Electroslag welding. It is an advanced welding process that is used to connect the thin ends of two metal pieces vertically together. Instead of the weld being used to the outside of a joint, it will take place between the ends of the two pieces. A copper electrode wire is fed through a metal guide tube that will act as a filler metal. When power is added, the arc is produced, and a weld is started below the seam and moved up slowly, creating a weld in place of the seam. Now let's move on to the advantages of welding process. Number 1. A good weld will be stronger than the parent or base metal. 2. Welding is a faster process compared to riveting and casting. 3. Complete rigid joints can be provided with the welding process. 4. Applicable to all metals and alloys. 5. Difficult shapes can be produced by welding. 6. Welding equipment is portable and can be easily maintained. 7. No noise is produced during the welding process as in the case of riveting. 8. The welding process requires less workspace in comparison to riveting. And 9. Any space of the joint can be made with these. Disadvantages of welding process. Number 1. It gives out harmful radiation, fumes, and spotless, which is a sudden sprinkle of spark. 2. Welded joints are more breakable and hence their fatigue strength is less than the member's joint. 3. Results in distortion and induces internal stresses. 4. It needs certain jigs and fixtures to hold metals properly. 5. Skilled workers and electricity are needed for welding. And 6. The inspection of welding work is more difficult and costlier than the riveting work. Now let's find out what are the applications of welding. The application of welding is so different and large that it would be no exaggeration to say that there are not any metal industry or branch of engineering that does not make use of welding, in one form or another, mainly in automobile industry. Some of the application of welding are shipbuilding, railway coaches, automobile chassis and bodybuilding, earth mover bodies, making window shutters, making doors, gates, and in all types of fabrication work. The welding process will be carried out.